Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 10.1 entitled Adding and Subtracting Polynomials. And today we're going to add and subtract polynomials. And we have to talk about the different kinds of polynomials there are, starting with a monomial. And a monomial is a number or a variable, or it could be the product of a number and a variable, or a number and several variables. So basically it's one term. So here we have 8. That's just one term, one monomial, or negative 55. Here we have 3 times x, but it's a number times a variable. So anytime there's a multiplication or a product, then that's considered a monomial or a term. It's not being added or subtracted to anything else, so it's by itself. Then we have the negative 5y squared. Remember, this would be negative 5 times y times y. Okay, but that's still a monomial because it's not being added or subtracted to anything. And then we have the 1/2 a times b cubed, or b times b times b. Okay, so you can have as many variables as you want. You could have the whole alphabet multiplied together, and that would still be a monomial. So it doesn't matter the length, it just matters that it's one term. It's a number, or it's a variable, or it's a product of numbers and variables. Now the degree of the monomial is the sum of the exponents of the variables on the monomial. Okay, so basically we want to look at the monomial and then decide what the sum of the exponents is going to be. Now, usually we're just going to see these where there's one exponent. So that exponent is going to be your highest power. So that's going to be your highest degree. Okay. So for part A here, the only variable we have is x, and it's being raised to a power of 5. Now we do have a 3 as well. So 3x to the 5th, that's our monomial. But the highest power is 5. And we don't have any other exponents to add with it. Now if we had something like 3x to the 5th times y to the 4th, then we would have to add those exponents together to get the degree. Okay? But here it's just x to the 5th, so my degree is going to be 5. Okay, for part B, I do have another monomial, negative 7 times x. That's a monomial. I want to look at the variable, and I want to look at the degree on the variable, which is a 1. So that's going to be the degree of my monomial. And for the 912 x to the 8th, again, I'm just going to look at the x to the 8th, and that exponent is an 8. There aren't any other variables being multiplied with that. We don't have any other exponents that we have to add together. So basically, if it's just a monomial, you look at the exponent that's on the variable. Okay, now we also have polynomials. And polynomials are where you have more than one monomial. And they're going to be added or subtracted together. So it's a sum of monomials. So you have x to the 4th minus 8. There's 2 terms there, or 2 monomials. 7x squared minus 4x plus 6. You have 3 monomials, all added and subtracted together. Then you have 5x to the 3rd, 9x squared minus x plus 14. So there you have 4 terms. You have 4 monomials that are all added and subtracted together. Now we have a special name for just one polynomial. That's a monomial. A binomial is when you have a polynomial that has 2 terms. So like the x to the 4th minus 8. That's a binomial because there's 2 terms. There's 2 monomials. A trinomial is going to have 3, just like a tricycle. So you have 7x squared minus 4x plus 6. That's a trinomial. Okay. Now, when we write our polynomials, we usually write them in standard form. So even if it's a binomial or a trinomial, you're going to write it in descending order to get it in standard form. And we've been doing that with our quadratics when we've been graphing them. Okay, so this concept will be very familiar to what we've been doing. And the degree of the polynomial is the largest exponent of any single term. So basically, once you put them in descending order, that first term is going to have the highest exponent in it. So that exponent will be the degree of the polynomial. So in example 2 here, we're going to practice that. We want to write everything in descending order and then state the degree and name it, tell how many terms there are. So part A, I have negative 3x squared plus 7x to the fourth. Well, my x to the fourth, that's a higher power because I have more x's. I have 4 x's. This only has 2. So we'll have 7x to the fourth first minus the 3x squared. Now that polynomial is in descending order. The degree is the biggest exponent, so that's a degree of 4. And then it only has 2 terms, so this would be a binomial. Okay, for part B, I have an x, I have 4x, and a 2, and a negative 7x squared. So it's almost in order, but I need that negative 7x squared to come first, then the positive 4x, then the 2. So again, my degree, I'm going to look at that leading term now. It has an exponent of 2, so degree of 2. And there are 1, 2, 3 terms, or 3 monomials added together. So this is going to be a trinomial. Now part C, we have to think. Okay, to put the terms in descending order, well, there's really only one term. So if I was going to put it in descending order, I would just write it again. Okay. The degree, well, in order to have a degree, you have to have an exponent. I don't have an exponent. I don't even have a variable with an exponent. So this is just going to be degree 0. There isn't one. And then it's just a single term, so this is a monomial. Now, it's also a number, so if you wanted to call it a constant, you could call it a constant. That's the fancy mathematical term for number. Now, if you had a polynomial that had more than 3 terms, we would just call it a polynomial. So we have special names for 1 and 2 and 3 terms, mono, bi, and tri. Anything beyond that, we just call it a polynomial. So if it has 4 terms or more, it's just a polynomial. That's how we would name it. Okay, so these skills are going to get you used to some vocabulary, and it's going to get you used to putting things in proper order, seeing the terms within the expressions, and that's going to help you when we're adding and subtracting polynomials. Now, when you're adding and subtracting the polynomials, it's basically like combining like terms. So all of your x squareds you're going to combine together. All of your x's will combine together. All of your numbers will combine together. But you have to have the same variable and the same degree. So you might have an x squared and an x. Now they both have x's in them, but one of them has 2 x's because it's x squared. So they have to not only be the same variable, but they have to be the same degree. They have to have the same exponent if you're going to combine them. And when we combine them, we combine the numbers out front of the variable. Now there's 2 ways we can do this. We can do horizontal form, or we can do vertical form. Okay, horizontal form is what I'm most comfortable with, but a lot of students like the vertical form. Does not matter at all which form you use. Whichever one makes sense, you go with it. Now, if you're using the horizontal form, you want to find your like terms. So I have a 2x squared, and then I also have an x squared over here. And I have an x, and I also have an x here. And then I have my -5, and I have a +6. So those are going to be my terms I'm going to combine together here. So the 2x squared and the 1x squared would be 3x squared. The x and the x would be 2x, and the -5 plus the 6 would be 1. So this is a good time if you have colored pencils or markers or highlighters and you want to use them, you can. You could highlight all of the terms that are the same in one color and then switch for a different term. Okay, now vertical format is really nice because it helps you line everything up. So you line up the x squared and then the x's and then the numbers. Okay, so this is kind of like what we did with elimination. You have to line up all the like terms. And then you just add the columns. So we'd have 3x squared plus 2x plus 1. So you get the same answer with whichever method you use. You just pick a method that works for you. Okay, so let's try this in example 3 here, and I can do one of each. Okay, for my part A, I'm going to do the vertical form. I have a binomial and a binomial. I have the x squared minus 7 and the 2x squared plus 2. So I have my x squared and an x squared and my number and my number. Okay, so underlining them in the same way or highlighting them or circling or boxing them, that will help you see which terms are the same so you can combine them together. And again, when we combine them, we're adding or subtracting the numbers out front. So I have 1x squared plus 2x squared, that's 3x squared. And then I have -7 plus 2, that's a -5. If you want to do the vertical, for part B, we have our terms in descending order here. So I have 4x squared minus 7x plus 2. And then I have to add up my other polynomial to it. Now there's 3 terms here, so these are trinomials. And I have to make sure I'm adding the like terms. So I'm going to have -x squared, and then the x, and then the -2. Okay, so 4 minus 1 will be 3x squared. -7 plus 1 will be -6x. And then the 2 and the 2 cancel. Now you could put a +0 if you wanted to, or you could just write it 3x squared minus 6x. So the vertical way is nice because it does help you put everything in descending order and then line everything up. For the horizontal, you don't necessarily have to put it in descending order. You can just mark them or find them and then add them together. The like terms, that is. Okay, now when we're subtracting, we can still use the horizontal or the vertical form. We're still combining like terms. However, you have to watch out for those sign changes. Because if you're subtracting a negative number, that's like adding a positive. Or if you're subtracting a positive number, that's like adding a negative number. Okay? So usually what I tell students to do is if you're going to use the horizontal form, here we're subtracting, we have our trinomial and then we're subtracting another trinomial. Draw in those little rainbows again and rewrite this expression so that you have changed all the signs. Rewrite it -x squared minus x minus 6. Then you can find your like terms, 2x squared minus 1x squared. And I have an x and an x. And then I also have my numbers. Okay, so now that I have all my like terms identified, then I can group them. So I have the 2x squared minus the 1x squared. That's just going to be an x squared. My x and my minus x or negative x will be 0x. And then the -5 minus the 6, that'll be -11. Now you don't have to write it with the 0x in there. If you wanted to write x squared minus 11, that's okay too. And this works with the vertical method as well. Again, the vertical form, you have to have everything in descending order and you have to line them all up in the same columns. Now when you do this though, you just have to remember that you're subtracting each and every one. So I like to put the subtraction out front and then put the whole second term in parentheses so I remember that I'm subtracting every single term in this bottom row. So I have 2x squared minus x squared, that's 1x squared. Then I have x minus the x, so that's a 0x. And then negative 5 minus the 6, that's negative 11. And again, you can write it as just x squared minus 11. So I think for subtracting, the horizontal form works a little better because in the vertical form, usually students forget to subtract every single term. And you could distribute that negative in if you wanted to, and then rewrite it as addition. So you could write 2x squared plus x minus 5 plus negative x squared minus x minus 6. So you could write it like that. Instead of subtracting a positive, you could add negatives. Then you don't have to worry about subtracting every single term. You can just add up the columns. So that's another way to rewrite it and get the same answer. But just be careful with your vertical form. If you really like the vertical form, be careful with the subtraction so that you don't forget to subtract the terms. Okay, so let's take a look at example 4 here. This will be our last one. And again, you can do this horizontally or you can do this vertically. I'll do one of each. Okay. For part A here, I have 12x cubed plus x squared, so that's a binomial. It's in descending order. And then I have 18x to the third minus 3x squared plus 6. That's a trinomial. It's also in descending order. And since I'm subtracting, if I'm doing the horizontal form, I'm going to distribute that negative to every term in the parentheses that comes after that subtraction or that negative. So I'll have 12x to the third plus x squared. Then I'll have a minus 18x to the third plus 3x squared minus 6. Then again, I want to go through and I want to find my like terms. So I have an x to the third. There's another x to the third. Don't forget the minus with the 18 or the negative with the 18. Let's see, I have an x squared and another x squared. And then I just have the negative 6. He's the only term there. So when I get done, I'll just kind of tack him on at the end. He doesn't have anybody to be combined with, but I still have to include him. So my x to the thirds, I have 12 minus 18. So that would be negative 6 x to the third. The x squared and the 3x squared would get me 4x squared. And then I just have the minus 6. Don't have anybody to combine him with, so I just put him on at the end. Okay, now notice this polynomial, I get a trinomial for an answer. So I was adding a binomial and a trinomial, and I got a trinomial. And there's also a term missing. There's no x term, so there could be a plus 0x written in here too. Okay, for part B now, I'll do the vertical method. So my first term, or my first polynomial has 3 terms, so it's a trinomial. So I have 3a to the third minus 4a squared. Now, since I'm doing the vertical form, I'm going to add in a placeholder here. I'm going to put plus 0a and then plus 3. That way I have all my terms in descending order, and I've got this plus 0a for like the placeholder for the a term that this polynomial didn't have. And then I'm going to subtract, let's see, a to the third lines up here, plus 3a squared minus a minus 4. Now again, if we're subtracting, you have to remember that you're subtracting every term. So I have 3a to the third minus 1 will get me 2a to the third. Negative 4 minus 3 is going to be negative 7a squared. I didn't have any a's in my first polynomial, but I'm subtracting a negative a, which means I'm adding a positive a. And then 3 minus a negative 4 is like plus 4, so that's a plus 7. Okay, so it's good to do the vertical form and have all your terms accounted for. Put that placeholder in there because sometimes students put the 3 in this spot and then the 3 lines up with the a and they try and combine terms that aren't alike. So that's another tip for doing the vertical form is that you have to watch out and make sure you're subtracting every term and you have to make sure you have your terms lined up appropriately. But again, some students really like the vertical form and they master all those little technicalities and they do great with it. Some students prefer the horizontal form. That's totally fine. Whichever method you prefer, you'll get the same answer. Okay, so practice these problems out of your book. Remember the odds are in the back so you can check them. If you have any questions, make sure you're coming in to see us for help before school. And if you have any other questions, let us know in class.